For cables over 600 volts, minimum cover requirements are not specifically provided in the National Electrical Code. However, the National Electrical Code does provide guidance in Section 300.5d, which states that cables over 600 volts shall be installed in accordance with the requirements for cables 0 to 600 volts, unless otherwise specified by a qualified person. This means that the minimum cover requirements for cables 0 to 600 volts in Table 300.5 can be used as a general guideline for cables over 600 volts, but may be modified as needed based on the specific conditions of the installation. Additionally, for cables over 5,000 volts, the National Electrical Safety Code should be consulted for additional requirements. When installing underground cables, understanding the applicable codes and standards is crucial for ensuring safety and compliance. The National Electrical Code, or NEC, provides a comprehensive set of guidelines for electrical installations, including those involving underground cables. Section 300.5 of the NEC specifically addresses underground installations, outlining requirements for cable burial depth, protection, and other relevant considerations. While Section 300.5 applies broadly to underground installations, Table 300.5 provides specific minimum cover requirements for cables operating at 0 to 600 volts. However, the question arises, what about cables operating at voltages exceeding 600 volts? The NEC addresses the scenario in Section 300.5d, which offers guidance on installing cables over 600 volts. According to this section, cables operating at voltages above 600 volts should generally adhere to the installation requirements specified for cables operating at 0 to 600 volts. This means that the minimum cover depths outlined in Table 300.5 can serve as a starting point for determining the appropriate burial depth for higher voltage cables. However, Section 300.5d includes a critical caveat. It allows for modifications to the standard installation requirements when deemed necessary by a qualified person. This provision recognizes that the specific conditions of an installation may warrant adjustments to the minimum cover depths outlined in Table 300.5. For instance, factors such as soil type, environmental conditions, and the presence of other underground utilities may necessitate deeper burial depths or additional protective measures. Therefore, when installing underground cables operating at voltages above 600 volts, it is essential to consult with a qualified person who can assess the specific conditions of the installation and determine whether modifications to the standard requirements are necessary. In addition to the NEC, the National Electrical Safety Code, or NESC, provides further guidance on the installation and maintenance of electrical power and communication systems, including those involving high-voltage cables. Specifically, for cables operating at voltages exceeding 5,000 volts, the NESC should be consulted for additional requirements beyond those outlined in the NEC. The NESC addresses a wide range of safety considerations related to high-voltage installations, including clearance distances, grounding, and insulation requirements. By consulting the NESC, installers can ensure that high-voltage cables are installed and maintained in a manner that minimizes the risk of electrical hazards and ensures the safety of both workers and the public. In summary, while the NEC provides a general framework for installing underground cables, including those operating at voltages above 600 volts, it is essential to consider the specific conditions of each installation and consult with qualified professionals to ensure compliance with all applicable codes and standards. For cables operating at voltages exceeding 5,000 volts, the NESC should also be consulted for additional safety requirements. By following these guidelines, installers can minimize the risk of electrical hazards and ensure the safe and reliable operation of underground cable systems. When dealing with underground electrical installations, several key factors must be considered to ensure safety, compliance, and long-term reliability. These factors range from understanding the applicable codes and standards to selecting the appropriate materials and installation techniques. Let's delve into some of these essential considerations in more detail. Firstly, understanding the National Electrical Code, or NEC, is paramount. As mentioned earlier, the NEC provides a comprehensive set of guidelines for electrical installations, including those involving underground cables. Familiarizing oneself with the relevant sections of the NEC, such as Section 300.5, is crucial for ensuring that installations meet the minimum safety requirements. Secondly, proper cable selection is essential. The type of cable used for an underground installation must be suitable for the voltage level, environmental conditions, and intended application. Factors such as insulation type, conductor size, and cable construction should be carefully considered to ensure that the cable can withstand the stresses of underground burial and operation. Thirdly, appropriate burial depth is critical. The depth at which an underground cable is buried plays a significant role in protecting it from physical damage and ensuring electrical safety. As discussed earlier, Table 300.5 of the NEC provides minimum cover requirements for cables operating at 0 to 600 volts, while Section 300.5d offers guidance for cables operating at higher voltages. Fourthly, adequate protection from physical damage is necessary. Underground cables are susceptible to damage from digging, construction activities, and other external factors. To mitigate this risk, cables should be protected by installing them in conduit, encasing them in concrete, or using other appropriate protective measures. Fifthly, proper grounding and bonding are essential for electrical safety. Grounding and bonding help to minimize the risk of electric shock by providing a low impedance path for fault currents to return to the source. All metallic components of the underground cable system, such as conduits and enclosures, should be properly grounded and bonded in accordance with the NEC. Sixthly, accurate documentation and record keeping are crucial. Detailed records of the underground cable installation, including cable type, burial depth, and location, should be maintained for future reference. This information can be invaluable for troubleshooting, maintenance, and future modifications to the electrical system. Seventhly, regular inspections and maintenance are necessary. Underground cable systems should be periodically inspected and maintained to ensure their continued safe and reliable operation. Inspections should focus on identifying any signs of damage, corrosion, or other potential problems. Maintenance activities may include repairing damaged cables, replacing corroded components, and verifying the integrity of grounding and bonding connections. Eighthly, coordination with other utilities is essential. Before undertaking any underground cable installation, it is crucial to coordinate with other utilities in the area to avoid conflicts and prevent damage to existing underground infrastructure. This may involve obtaining utility location information, marking underground facilities, and coordinating excavation activities. Ninthly, awareness of local regulations and permitting requirements is necessary. Underground cable installations may be subject to local regulations and permitting requirements. It is important to familiarize oneself with these requirements and obtain any necessary permits before starting the installation. Tenthly, use of qualified personnel is paramount. Underground cable installation should be performed by qualified and experienced personnel who are knowledgeable about the applicable codes, standards, and best practices. This helps to ensure that the installation is performed safely and correctly, minimizing the risk of errors and potential hazards. By considering these factors and following the guidelines outlined in the NEC and other relevant standards, installers can ensure that underground cable installations are safe, reliable, and compliant with all applicable requirements. Remember, safety should always be the top priority when working with electrical systems, and proper planning and execution are essential for achieving successful outcomes. In addition to the factors already discussed, several other considerations are important for ensuring the safety and reliability of underground cable installations. Let's explore these additional aspects in more detail. Firstly, soil conditions play a significant role. The type of soil in which the cable is buried can affect its thermal performance, corrosion resistance, and mechanical protection. Sandy soils, for example, tend to have good thermal conductivity but may be more corrosive than clay soils. Rocky soils can pose a risk of physical damage to the cable if not properly backfilled. Secondly, environmental factors can influence cable performance. Underground cables are exposed to a variety of environmental factors, including temperature fluctuations, moisture, and chemical exposure. These factors can accelerate cable degradation and reduce its lifespan. Selecting cables with appropriate environmental ratings and implementing protective measures can help to mitigate these effects. Thirdly, cable pulling techniques are critical. The method used to pull the cable through underground conduits or ducts can impact its integrity. Excessive pulling force can damage the cable insulation or conductors, leading to premature failure. Using proper cable pulling lubricants and techniques can minimize the risk of damage during installation. Fourthly, splice and termination methods are important. Splices and terminations are critical points in the cable system where connections are made between cable sections or to equipment. Poorly executed splices and terminations can result in electrical faults, overheating, and equipment damage. Using approved splicing and termination kits and following manufacturer's instructions are essential for ensuring reliable connections. Fifthly, cable identification and marking are necessary. Properly identifying and marking underground cables is crucial for future maintenance and troubleshooting. Cables should be clearly labeled with their voltage rating, circuit designation, and other relevant information. Markers should be placed at regular intervals along the cable route and at all access points. Sixthly, trenching and backfilling procedures are important. The way in which the trench is excavated and backfilled can affect the long-term performance of the cable system. The trench should be wide enough to accommodate the cable and any required protective measures. The backfill material should be free of sharp objects that could damage the cable. Seventhly, locating and marking underground utilities is essential. Before excavating any trench, it is crucial to locate and mark all existing underground utilities in the area. This helps to prevent accidental damage to buried infrastructure and ensures the safety of workers. Eighthly, safety precautions are paramount. Working with underground cables can be hazardous, especially when dealing with high voltage systems. Strict safety precautions should be followed at all times, including wearing appropriate personal protective equipment to energizing circuits before working on them, and using insulated tools. Ninthly, documentation and record keeping are crucial. Accurate documentation of the underground cable installation, including cable specifications, installation details, and test results, should be maintained for future reference. This information can be invaluable for troubleshooting, maintenance, and future modifications to the electrical system. Tenthly, ongoing maintenance and inspections are necessary. Underground cable systems should be periodically inspected and maintained to ensure their continued safe and reliable operation. Inspections should focus on identifying any signs of damage, corrosion, or other potential problems. Maintenance activities may include repairing damaged cables, replacing corroded components, and verifying the integrity of grounding and bonding connections. By considering these additional factors and following industry best practices, installers can maximize the safety, reliability, and longevity of underground cable installations. Remember, a proactive approach to planning, installation, and maintenance is essential for ensuring the successful operation of underground cable systems.